Hey everybody, it's Miss Phoebus and I'm back with another lesson, lesson 60. We're looking at scatter plots and linear regressions. Now scatter plots should be something that you talked about in middle school, but linear regression should be something new. And you have to use your TI-84, nothing else, TI-84 graphing calculator. Okay, so make sure that you have that up and you're practicing along with me. So the words that you may know already, scatter plot. A scatter plot is a collection of data points that usually creates a pattern to show relationships between variables. Another phrase you may not know or know, bivariate data is just data based on two different variables. So bi meaning two and variate meaning variable. So two variable sets of data. Regression is a method of creating an equation to model a set of data. We will write linear and nonlinear regression equations. But this is where the graphing calculator comes in. You don't have to do anything except take the table of values that are given to you, plug them into the calculator, know which buttons to push, and it will pop out the equation. So if you ever have a table and they're like, hey, write us an equation, this is something that you can do if you know how to use the calculator to get you a regression model. All right, we're also going to talk about correlation coefficient. It's a number that shows the strength or weakness of a data set to its regression equation. In our skills, I can represent quantitative data on a scatter plot by hand. We usually do this in class and we work on graphing them by hand. We're not going to do that so much here. We may skip those parts, including choosing an appropriate scale for each axis, which is something that we have been practicing. Skill 98, I can fit a given function class, which we're going to focus on linear today, to data by using a graphing calculator or by using knowledge of those functions. And then from a scatter plot, I can describe how two quantitative variables are related. We're also going to look at our standards representing data on two quantitative variables on a scatter plot and describe how the variables are related. We're also going to work on fitting a linear function for a scatter plot that suggests a linear association. So we are on page 303 of the notes, and on page 303 you should see a box that's labeled correlation. And so a correlation is the relationship between two variables that are being compared, and we have different types of correlation. So I have these quadrant ones that are drawn for us here, and we're going to look at examples of strong positive correlation, weak positive correlation, strong negative correlation, weak negative correlation, and then no correlation. So our strong positive correlation is going to have dots that are really close together and they're trying to form one single straight line. Now, most of the time they don't fit on one single straight line, but they're going to get really, really close and they're going to be kind of tight knit, and that's going to represent a strong positive correlation. The strong part being how close the dots are. The positive being the, hey guys, this, if I drew a line through it, that line has positive slope. All right, weak positive, still that positive slope, right? Still going up and to the right. But do you see how the dots are more spread out? So it's not a strong positive, it's weak. And it's weak because those dots have gotten further away from the line that goes through the middle of the data. All right, we have a strong negative correlation where the dots are really close together. But look, my slope is now a downward slope, a negative slope. And then a weak negative would be still having that downward negative slope, but do you see how those dots are a lot further away from each other and from the line? All right, and then we have some examples of no correlation. So no correlation would look like just a bunch of dots just kind of scattered around, no pattern of positive or negative. Even a vertical line, even though they are close to that vertical line, is not considered, it's considered no correlation, just like it would have an undefined slope. There's not really any relationship amongst those two variables that are being compared. And then we would have, if we were talking, hey, we're talking about linear correlation, and then we got a non-linear type curve. You see how that kind of looks like a parabola? That would imply that there's no linear correlation between the variables. Now, we are going to talk about non-linear pieces, and that will be later in the week. And they have like their own job to do, and we'll talk about like how to tell and all of that kind of stuff later. So here we have example 1. The graph below shows the relationship between the number of points scored on a test and height. So I have two variables, height and points scored on a test. So the question is, and we're getting a feel for what the graph looks like and what the graph is telling us, but also what do we know about these variables? So what type of correlation is this? So how tall you are determines how many points you're going to get right on a test. What do you think? No, there's not related. Short people don't get questions wrong more or right more often than tall people. Your height has nothing to do with how many points you are going to score on a test. So because these two variables are being compared, we're really interested in the relationship between the variables. And so that's where that correlation, you see that relation in there, that means that we're looking at the relationship. And there's no correlation. There's no relationship between the variables. It doesn't make sense for there to be a relationship. Now, if we wanted to force a relationship, we would have to do a lot of experiments. If we're like, no, 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 we are sure that height is going to determine how many points you score, we're going to be having to run some experiments. We're going to be having to give short people tests and tall people tests and make sure that they have been to the same classes and things like that. Running experiments to prove or to suggest that these two variables are related. But common sense tells us that this isn't always the case. What is the relationship between the variables? None. The height and points, not related to each other. No relationship. All right, so here we go. The graph shows the relationship between age and height. Now, this is only good up to a certain point, right? Because at some point in time, you stop growing and you maintain a certain height, and even when you get into your old age, you start shrinking. So kind of ignoring that last part, let's think about little kids as they're growing up. Their age is going to influence how tall they are. And if we know that we have a kid that's 6 years old and they're really, really short, like they're the size of a newborn, we know something's wrong with them because they're supposed to be gaining height as they grow. We have charts and things based off that, and that's what doctors expect to see and all kinds of things. So if you notice, we have these dots following a path, an upward trajectory. So this is going to be a positive correlation. So what is the relationship between the variables? Now this is like a sentence where we're talking about the variables. And so as age increases, as age goes up, height increases, height goes up. Now, when both of the variables are increasing, age is increasing and height is increasing, when both of them are doing the same thing, they're both increasing, that's going to create a positive correlation. So you're going to have in your homework and maybe even on the EOC test, things where it's like, hey, which situations are going to be talking about a positive correlation, and you're going to have to go through and say, okay, as this increases, what does this other one do? Does it also increase? If so, then it's positive. If this increases, oh, this decreases. That's not going to be a positive. We want them to head in the same direction. So you need to have that in your mind because you aren't going to be presented necessarily with a scatter plot. You're going to be presented with a situation to where you have to think, okay, as this increases, what happens to this? Or as this decreases, what happens to this? And you need to think about those variables, and if they're headed in the same direction, we're going to say it's a positive correlation. All right, the graph below shows the relationship between price of an object and the number of items purchased by customers. So we have price. As price is going up, look at this, as price is increasing, the number purchased has decreased. We've got a very low piece, okay, and we've got this downward trajectory, which would mean a negative slope. So what type of correlation is this? This is a negative correlation. So what is the relationship between the variables? So what I want you to do is I want you to complete this sentence, and you can pause the video and you can write this down. As price increases, number of items purchased blank. As price increases, number of items purchased decreases, and because one is increasing, the other is decreasing, they're opposites of each other, that's going to indicate a negative correlation. Now in these, you do not have to talk about strong and weak and that kind of stuff, but we're focusing on that later on when we get to the thing called correlation coefficient. That's going to actually tell us, it's going to be a number that tells us how strong and weak our data is. All right, so these are the things that you're going to use on the graphing calculator to help you graph a scatter plot. So you can actually graph a scatter plot. It's actually pretty cool. So the first thing you're going to do is you've got to get your data into the table. So there is a stat button. Let me pull up my calculator. All right, so stat is right here. I'm going to touch it. It's going to become red. So stat is right there, right next to your X button under the delete key, just to the left of your directional pad. Okay, so stat stands for statistics, and while you're in there, there's going to be several things that you can do. But the very first thing that we're going to talk about is once you hit stat, you're going to hit enter, and that means you're going to edit, and you're going to be editing some lists. Now, this is where you put your table in. So you're going to type all of your data into L1 and L2, L1 being list 1, that leftmost column, and L2 being the one right next to it. L3, L4, L5, we don't really care about, okay? But L1 and L2 are what we're going to type our table in. And because we have bivariate data, 2 variables, we're going to have like X's and Y's, you are going to fill in 2 columns. All right. You're going to hit second, y equals enter, enter. You only have to do this once per time that you use your calculator. And what that's going to do is it's going to allow us, let me go ahead and do that for you. Once you have your table in, you do second, y equals, and do you see how it says plot when we're in stat plots and the plot is off? If we want to plot a scatter plot and look at the dots, you would have to turn the stat plot on. So that's where the enter comes in, and then it'll turn that stat plot on. And then Zoom 9 will zoom you in to exactly where your table is. So in class, if you were here with me, we would be doing this over and over and over again. I'd be like, hey, did you get it? Hey, are you pushing the right buttons? Hey, did you get stuck? So you need to be practicing this in the homework and then letting me know if you're having trouble working the calculator, because then I can address that. Okay, so you need to be practicing and making sure you're referring back to these notes, and you can go through. And I really wish you had a physical calculator. Most of you don't, and I really wish you did, because then you would start getting that muscle memory. But definitely try to go through the steps and maybe even say it out loud. Okay, I'm going to second, y equals, enter, enter, zoom, 9. And then maybe just even hearing yourself say it, it can kind of get in your head every single time. I know it sounds weird talking to yourself, but the more that you either can write something or hear something, I mean, it's different for everybody, but you can get that into your head, and it will be something that would be helpful for you. All right, so a line of best fit and this you may have talked about in middle school, is a straight line that best represents the data of a scatter plot. This line may pass through some of the points, none of the points, or all of the points. It's just kind of which one best fits. If you've ever drawn the line by hand and tried to figure out how to write the equation of the line, you found the equation of a trend line, not the line of best fit. In order to find the line of best fit, you need some sort of technology to help you, because technology is going to be the best way to find the line that best fits that data. So how do you get the equation of the line of best fit from your graphing calculator? Well, you're going to type in a table. So you're going to hit stat and enter. You're going to get all of your data into L1 and L2. Then you're going to hit stat, and then that button means right. So you're going to, on the directional pad, hit the right button. And you want to choose option 4, which for us right now is going to be a linear regression model. It says linreg, I'm pretty sure. And you're going to hit enter many times until you see linreg at the top. So it's going to ask you a lot of questions. You're just going to keep yes, yes, sure, sure, yeah, yeah, yeah. And then you stop when it pops up and it says linreg at the top, and it's got all the stuff for your equation. Okay, so again, not a whole lot of math is going on. We're letting the calculator do all the tedious stuff, the stuff that's just like, the kind of stuff that takes a little bit of time. But then we have to, using the technology, be able to interpret it. So that's where our side of the things come from. Our side of the math comes from. All right, so we're going to write the equation of the line of best fit for the relationship between the total fat, X, and the total calories, Y, for various sandwiches. So we don't know what the fat, or we don't know which type of sandwich is what. We just know fats paired with calories. So 5 grams of fat and 300 calories go together. 25 grams of fat and 500 calories go together. Okay, so that's what we know. So this is X and this is Y. All right, and we have a table and a graph. So we see with our graph, we see that the dots are pretty close to building a straight line. There's some points that are actually on this line. But what we need is we need an equation. So we're going to break out our calculator. And on this calculator, we are going to go to stat and enter. Okay, and what we're going to do is we're going to type in all of the X values. Now it's easier to type in all of the X values and then go back and get all of the Y values, because I'm going to hit 5 and then all you got to do is hit enter and then it bumps you down. So it's easier to do it that way than to do it 5 and then 300 and then 9 and 260, but it's not like impossible. You could do it that way. I find it easier to fill in all my X values. The problem is that you have to make sure you are typing in everything correctly. It's very easy to maybe get distracted and you're typing in 28 and you think you hit enter and then you type in 30 and now you've got 2,830 calories versus 28. So you need to be very cautious. One of the first things, if somebody's not getting something right, I'm like, I want to see what you have in your calculator. And a lot of times it'll be a transposed digit. Instead of 34, they'll put in 43. Or they are missing a piece. They skipped over a number. So you have to be very diligent in filling these things in. All right, so I filled in my L1, and now I'm ready to fill in L2. So I'm going to hit right, and what numbers go in here matters because I have to make sure that 300 is in the same row as 5. If I don't make sure that that's what's going on, then I'm going to be basically matching up my variables with different numbers than they're supposed to. It will give me an equation. It will give me an answer, but that's not what I'm looking for. I'm looking for the one for this exact table, not just to get an answer. So 320. And so this is probably of the work, the most tedious, is just trying to get all the stuff in the calculator, make sure that it's right. We're just typing stuff in, that's all. And that means it's not hard. It's just trying to make sure you're accurate and know how to get to the spot. That's the important part. All right, 585. Okay, now when I go through, I can even tell some things to make sure that I'm even on the right track. So do you see how the slope of this line is positive? We also have a y-intercept that's around 200, so hopefully I'm getting the same thing when I go through and I get my linear regression equation. So when I get this equation, it's going to be in the form y equals mx plus b. However, the statisticians got a hold of this. They're a weird bunch, and they say, hey guys, we're not going to call that m. We want to write this as y equals ax plus b because a comes before b, and we're weird like that. And so the rest of the world goes, okay, we'll let you do that for now. But when we're teaching in middle school and algebra 1 stuff, we're still going to use m because we like it. So anyway, when this pops up, it'll actually show the y equals ax plus b in the stuff to write the equation. All right, so what we're going to do is we're going to hit stat, because this is all about stats, right? And then we're going to go right over here to calculate, and we want to calculate a linear regression. Look right there, ax plus b, that's what we want to calculate. And the calculator is going to actually give you the a and the b to write the equation. So you can go down and you can click enter, or if you want to just choose 4, you can. While we're in here, I want to go ahead and show you some other things. So we'll use the one variable statistics later on. We're doing the linear regression. In a couple days, we'll do the nonlinear, so we'll be looking at a quadratic regression, but there's even a cubic and a quartic regression. We don't ever use this linear regression, which basically just changes A and B and puts b with x instead of a with x. We don't have to worry about that. That's a natural log regression. We don't have to worry about that. But look here, an exponential regression. So quadratic and exponential are going to be ones that we will talk about on our nonlinear ones. And then there's some other stuff. Okay, but we're interested in 4. I'll just go ahead and hit 4. We're interested in 4. And then this is where you hit enter a whole bunch. It's like, hey, should I use L1 for my X's and L2 for my Y's? And we're going to be like, sure. We will not have a frequency list. We can store a regression equation and have it pop up later, but we'll skip that for right now. So we're just going to hit enter, 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 and it's going to calculate, and it's going to give me a slope and a y-intercept, and that's what we're going to use to write our equation. Now, if they give you decimal places, we're going to like round to the nearest hundredth. So 11.63x plus 195.21. So we have our regression equation, and then what I do want to show you, we haven't looked at this yet, is the actual scatter plot for the data. So remember, we hit second y equals and make sure our stat plot is on. As long as I don't clear out my calculator, then it should stay on. Later on, and the problem happens during the end of course, if you're doing a scatter plot problem, and then later on you want to graph, y equals x squared plus 3, then it might cause an error because your scatter plot is still on. But you can always clear that up with second plus 712, or you could just come back up here, second y equals, because see that stat plots right there, you can turn your stat plot off. Going to 4 would also turn off all your stat plots. We only turn on one of them. All right, so what I'm going to now do is I'm going to show you the how to get the scatter plot, and we're going to hit zoom 9. If I hit zoom, and then 9 is zoom stat. So what it does is it's going to zoom in to where the table is set. And there is our scatter plot, which is very similar to what we have here. If I go to y equals and type in this 11.63x plus 100, 95.21, then graph it. I have a picture very, very similar to what I have over here in my picture of my graph. Okay, so the equation that we're writing is something that you can add into y equals, and you can add that to a picture of a scatter plot. Now, when I change my scatter plot by changing my table, if I don't go to y equals and clear out the line, it's still going to be there. So just keep in mind that there's lots of pieces, right? We filled in the table, we wrote an equation, put the equation into y equals, so there's several parts that are having to be controlled. So if you just redo a table and then go to look at the graph, you might see a random line from this other problem that we did. So we're using the graphing calculator and helping us write an equation, a line of best fit. All right, so write the equation of the line of best fit using the calculator, sketch the scatter plot of this data from what you see on the graphing calculator. So what we're going to do is we're going to go back in. I'm going to go to y equals, just like I was telling you. I'm going to clear out that line because I don't need it anymore. And then I'm going to go to stat, enter, and then now I want to clear out these tables. So you have some options. You can overwrite what's in the list. You can also go up, but do not delete. If I hit delete here, I will delete the whole entire list, and later on it will cause a problem. So what you can do is you can hit clear, and it wipes out everything, and then enter, and it will wipe out the whole entire row. So you have some options, but one option should not be deleting the whole entire list. So I recommend going up, highlighting the list name, hitting clear, and enter. And there are usually several people who I have to go around and help them get their list back. Now, if let's say for a second, I'm going to be bad. I'm going to be bad. Second, oh, I deleted some lists. Oh no, I'm going to delete them all. Oh no, and then I try to put stuff in, the calculator is not going to have any of it. It's going to have some issues. So I can do second plus 712, and let's see how much trouble I'm in. Looky there. They all came back. Okay, so second plus 712 is a good thing to know, especially for the end of course, because nobody can help you with a graphing calculator, and I am so sorry about that, but it's the rules of the test, and they were not made for COVID. So second plus 712, second plus 712, second plus 712. So second plus 712 is your friend. You need to get it in your head somehow. All right, so we're going to put this table in. It's only got 5 points. So we're going to hit stat and we're going to hit enter. And remember that all of the points on top of the table are going to be our x values. All the points on the bottom row of the table are going to be our y values. And so 85, 95, 105, 115, and 125. Now I've got $3.89, $2.78, $3 and a penny, $3.23, and $1.69. Okay, and then we're gonna hit graph. Now, because I cleared out my graphing calculator, my stat plot isn't even there anymore, and probably wasn't going to be any closer. So you may be like, well, where is everything? Well, remember that right now the max is 10, so we're up at 80, or we're out at 85, so we're over here like way on down the road, and we want to tell the graphing calculator we want to see the scatter plot. So first we have to turn on the stat plot. So second y equals, and if you did not clear out your stuff because Miss Phoebus was going crazy and just cleared hers out and you didn't, okay, don't worry about it. But now you definitely should hit zoom 9. Zoom 9 will take you to your scatter plot. Now when I ask you to sketch this, I'm just asking, something that's very similar to what we can see here and here here, and here, and here. All right, those look good. They can be closed points. I think on your graphing calculator they have them as open because what they do later on is when our regression equation, when that line that we draw actually goes through and hits it, it'll close that in and you can see, ooh, it fills that point in, it hits it right on the mark, not like almost. So that is our scatter plot. So if you ever have to sketch one for me, that's what I'm asking for. About where are the points. Nothing super accurate. You do not have to label the X and Y axes at this point in time. It would be nice to have variables there, but it'll be okay. I'll get over it because you're pulling it from the calculator. All right, we're going to write a regression equation. So I'm going to scoot over here. We're going to hit stat and enter. There is our list. It's still in there. I'm going to hit stat right 4. And then hit enter a whole bunch of times. And there's our regression equation. Now, it is negative. Our slope is negative, and do you see how this follows like a downward path? So it should have a negative slope. So when we go through and write this, now we have a limited number of decimals. It would probably be better to err on the side of writing all of the decimals than rounding too much. So don't round too much. If there's, a reasonable number of decimals, you can write them all. All right, so let's go back into y equals. And hopefully you're doing this along with me. If not, you might want to do it. Maybe pause the video and try to see what you can do. 7, 5, and then I'm going to look at the graph, and that goes through the middle of the data. It doesn't really hit any of the points, but that's okay. It gets pretty close. It gets close to that very, very middle one, kind of close to that top one. So it's going to try to be in the very middle of the data. So that's the main point of this lesson is, can we get our data into the graphing calculator and can we use it to write a regression equation?